All right, let's jump right in. Today, we're looking at something pretty bold coming out of MIT. It's making huge waves in the world of protein prediction, and that's a field, well, it's fundamental to understanding life itself. But to really get why this new development is such a big deal, we've got to start with a question. Think about it. What happens when a massive scientific breakthrough gets locked away, when the keys are only held by a handful of people? And that brings us right to AlphaFold 3 from DeepMind. Now, this thing was and still is an incredibly powerful tool, a total game changer. But, and this is the huge but, most of its code was kept private. Locked down, kept under wraps. So this lack of access, it became a real roadblock for researchers. It created what the scientific community started calling the AlphaFold 3 challenge. It was basically a call for more transparency, for things to be more open. I mean, think about it. You've got this incredible tool that can predict the super complex 3D shapes of proteins, which is just crucial for everything from developing new medicines to creating new materials. But researchers were stuck on the outside looking in. They couldn't peek under the hood, they couldn't tweak the code for their own work, and they definitely couldn't build on it. So you can feel this frustration building up across the entire scientific world, right? It really set the perfect stage for a new player. It was time for a challenger to step into the ring.
And then, in late 2024, one of the world's top research institutions decided to step up. They had an answer, and that institution, it was MIT. Their answer was called BoltzGen, and it was a direct response to what everyone was asking for, a tool that wasn't just powerful, but was also completely open. So, what exactly is BoltzGen? Well, it's a completely open source model that came out of MIT's Jameel Clinic. Its whole job is to predict the 3D structures of proteins, sure, but also DNA, RNA, and other molecules. And those two words, fully open source, that's the magic right there. And look, BoltzGen is not just some open source copycat. Not at all. It was built from scratch to be a real powerhouse. We're talking state-of-the-art accuracy right up there with the best of them. It's fast, it's modular, which is cool. It means scientists can actually pull out pieces and plug in new ones to experiment. And, maybe most importantly, it ensures reproducibility, which, is the absolute bedrock of good science. And this really gets to the core of the whole thing. It's about the power of being open. It's a totally different philosophy for how science should be done. So let's just put these two side by side, okay? You've got AlphaFold 3, incredibly powerful predictions, but it's basically a closed proprietary tool. Then you have BoltzGen, same top-tier accuracy, but it's a completely open source platform. It's not just a tool to be used, it's a platform for discovery. So what does open source actually mean in practice? It means anyone, any researcher anywhere can get in there and look at the code. They can see exactly how it works. They can change it for their own projects, and this is huge. They can contribute back and make it better for everybody. The real-world impact of this? I mean, it's massive. This could seriously speed up drug discovery because you have more people trying more creative things. It could help us design better enzymes for all sorts of industries. And it just opens the doors for students and researchers at smaller schools or labs to get their hands on this kind of cutting-edge tech. Now, a tool this powerful doesn't just pop into existence out of thin air, right? It's built on a foundation. It's standing on the shoulders of giants, you could say. And it's all fueled by decades and decades of shared public data. We're talking about years of painstaking work by scientists from all over the world, building these huge public databases like the Protein Data Bank and UniProt. These are just massive global libraries of biological info, built one piece at a time by the entire community. So really, BoltzGen is the ultimate proof of how powerful that collaborative spirit is. It's what's possible when science and data are shared openly for everyone for years and years. So what's the big takeaway here? We have to see BoltzGen as more than just a new piece of software. It's something way more important. It's a catalyst for science itself. In the grand story of how AI is changing science, this is a really big chapter. You could call it the MIT moment. It's where that top-level academic brainpower meets a hardcore commitment to open source and sharing. And that really is the best way to look at it. It's not just a challenger to AlphaFold 3. It's a catalyst. Its very existence is meant to spark new ideas, new projects, and brand new discoveries all over the world. And that leaves us with a really inspiring question to think about, doesn't it?
When you put tools this powerful into the hands of everyone, when science is truly open, what's the next big thing we're all going to discover?